Okay, good morning. Today we'll discuss about projection of solid lines. In the last class, we have discussed projection of points, and today it is extension of projection of points because the lines are, if you join the 2 points with the shortest distance, then they are called the straight lines. So, if you understand the projection of points, it is easy to understand the concept of projection of lines as well. Okay, we'll start our discussion here. As we all know, the vertical plane and two horizontal plane, two planes are there, and the lines, there the basic problems consist of lines parallel to VP or lines parallel to HP. Okay, so one plane the line will be parallel, the other plane it will be inclined at some degrees, either it is 0 or at some theta or 90 degrees. So 0 to 90 the angle varies with one plane, and the other plane the line is parallel. In such cases, how to draw the projection of lines, that we will see today. So the first we will take up lines parallel to vertical plane. When in that, the first aspect is the line is parallel to HP as well. Okay, here the line is parallel to VP as well as HP. This is our planes, and this is our line. The line AB is parallel to both HP and VP, and when the line is parallel to VP, okay, when the line is parallel to VP, we'll start the drawing with the front view, because when the line is parallel to VP, in front view you will see the true length of the line as well as the inclination of the line with HP. Okay, so because of that reason, when the lines are parallel to VP, we'll start with drawing with the front view. Okay, now see here, the line is parallel to VP means this distance, the distance of A from VP and the distance of B from VP must be equal. So then if these two are equal, then we will get the true length in the front view. So that is what I was talking about. When the line is parallel to VP, you will see the true length in the front view. And here the line is parallel to HP as well. So this distance of A and B from HP is also equal. Okay, so in the question they will give the distance of point A from HP as well as the distance of point from VP. Okay, or the distance of point from VP or distance of point from HP. So these things we have to look in for in the question. So first step in drawing the projection, the front view. So first we have to draw the front view, as I said. So in the front view, we need to identify the position of A dash or B dash with respect to XY. So you identify from the question what is the distance of point A from HP or distance of point B from HP. So once that is known, you draw the reference line XY and take this distance of A dash or distance of A from HP, and you draw a line from XY. So here the point A is 10 mm above HP. So the point is 10 mm above HP. Okay, so the point is as well, the front view is above XY line by 10 mm. Okay, now the point A dash is fixed. Now what is the thing you have to do? You have to find what is the orientation of this line with HP. So here the line is parallel to HP, so the front view is parallel to XY. So what is the length here? It is the true length, and it is 20 mm we are taking in this question. So once this 20 mm is drawn, now you drop a projection from B dash to XY. With this our front view is completed. So next what we have to do, we have to go for the top view. So the observer is seeing from the top. When the observer is seeing from the top, here since the distance of A and B is equal from HP, he will see the true length in top view as well. Okay, because the line is parallel to both HP and VP. So that is the reason. That's why this length is also equal. Now, for drawing the top view, we need to identify what is the distance of point A from VP. Okay, we need to find what is the distance of A from VP or B from VP. Either of these two conditions will be given in the question. We have to identify. So we are taking here the point A is 15 mm in front of VP. 15 mm in front of VP means the point in the top view is 15 mm below XY line. So this is 15 mm below XY line. So this is 15 mm below XY line. This point is A and the line is parallel to XY. So you complete this diagram. So this is the front, the projection of lines when line is parallel to both HP and VP. So next one is when the line is parallel to VP and inclined to HP. Okay, so inclined to HP. So we are taking this planes here and this is the line. The line is inclined to HP. So if you see here, it is some angle with HP. So because this line is inclined at some angle with HP, we will see the true inclination in front view as well as the true length in front view because the line is parallel to VP. The line is parallel to VP. So you will see the inclination of line with HP in front view. In front view, the observer is seeing from the front. You will see the true length of the line and as well as the inclination of the line with HP in front view. Okay. Now, as I said previously, when the line is parallel to VP, the distance of C and distance of D must be equal to VP. So this distance is known. That's why, because these two distances are equal, you will see the true length in the front view. So this is the front view. So for drawing the first step is to draw the front view. So for drawing the front view, you identify what is the distance of C from HP or D from HP. So that we have to look in for in the textbook in the question. So say I am taking the distance of C from HP is 5 mm. So this is the XY. The distance of C from the HP. C is at 5 mm above HP. So the C dash is 5 mm above XY line. And this inclination I am taking 40 degrees. So this is the 40-degree line. And what is the length of the line? I am taking the same 20 mm line. So this is the 20 mm length. You can see here the true length and inclination with HP is visible in front view. Okay. Now you project this D dash. You draw the projection of D dash, and with this the front view is completed. Next, what we have to draw? We have to draw the top view. So observer is looking from the top. When the observer is looking from the top, since the distance of C and the distance of D from HP are not equal, what he will see is he will see a reduced length. Okay, the length of this top view is less than the true length of the line. Okay, why? Because this length and this length is different. So he will see a smaller length of the line in when he is looking from the top. So that is what we have to understand. I mean, if you can visualize, that is easy. Otherwise, you can remember. If you are looking from the top, when the line is inclined to HP, you will see a reduced length. Okay. Now, what we have to do? We have to identify what is the distance of this point from VP. So this distance of C from VP we have to identify. That will be given in the question. So here I am taking that distance as 5 mm, and this distance, when this distance is known, now since this distance and this distance are equal, since the line is parallel to VP, this distance of C and distance of D from VP is equal. So that's why I will get a horizontal line here in top view. The top view is a horizontal line but of reduced length when the line is inclined to HP and parallel to VP. Okay. Next one is when the line is perpendicular to HP. Okay. When the line is perpendicular to HP, this is the third case. These are the planes and this is the line. So here you can see the line is perpendicular to HP. When the line is perpendicular to HP and parallel to VP. So first, since the line is parallel to VP, we'll first focus on the front view. So the front view, the observer is looking from the front and he sees that the distance, since the distance from these 2 points E and F from VP is equal, you will get the true length in the front view. Okay, once this front view is known, we have to draw the front view. For drawing the front view, we have to identify what is the distance of point E or F from HP. So this distance will be given in the question. You have to identify that distance. So once this distance is identified, you draw the reference line, then you take this distance. So in this question I am taking the distance of F from HP as 5 mm and this F is at 5 F is 5 mm above HP, so F dash is 5 mm above HP, above XY. So the front view, as I said, the front view is true length, so it is 20 mm. So from here to here you take 20 mm and this is the front view. So the front view is done. Now what I have to do, I have to draw the top view. So if I looking from the top, if I am looking from the top, see here this point will coincide with this point and you will see a point. Instead of seeing a line, I will see a point. So you can observe here, when the line is parallel to HP, I am seeing true length. When the line is inclined to HP, I am seeing the reduced length. When the line is perpendicular to HP, I am seeing a point. So these are the three conditions for the line parallel to VP. Okay, when the line is parallel to VP, it can have three conditions with HP: line parallel to HP, line inclined to HP, line perpendicular to HP. Now what I have to do, identify what is the distance of F from F from VP and draw the top view. Okay, so this distance is known, means I can draw the top view. So here I am taking 10 mm in front of VP, so top view is 10 mm below XY line. So this E and EF will be below XY line. So these are the projections of lines when the lines are parallel to VP. So the important points that we have to remember here: when the lines are parallel to VP, the true length of the line is visible in front view. So we have to start drawing the projection of lines with front view. So the second one is, when the line is parallel to VP, in front view you will see the true inclination of the line with HP. Okay, here this is parallel to HP, this is inclined to HP, and this is perpendicular to HP. Okay, so parallel to HP, inclined to HP, and perpendicular to HP. So this is the one point you have to remember. The second point is, when the line is parallel to VP, the top view will be a horizontal line. The top view, the distance of all the points will be equal from XY. Okay, when the line is parallel to VP, here this distance and this distance is equal, and this distance and this distance is equal, and the distance of these 2 points is equal. So the distance of AB from XY is equal, or CD is equal to is equal from XY, and EF is also equal from XY. So these are the points we have to remember when the lines are parallel to VP. So second one is lines parallel to HP. When the lines are parallel to HP, again we have three conditions. the line can be parallel to VP, the line can be inclined to VP, and the line can be inclined to HP. Perpendicular to VP. So we will take up the first one. Line is parallel to VP. When the line is parallel to VP, so here the line is parallel to VP, and here we are focusing on lines parallel to HP. When lines are parallel to HP, we'll start with the top view. Okay, the lines are parallel to HP. This distance and this distance are equal. So while looking from the top, you will see the true length in top view. So this is the true length. Okay, lines parallel to HP, in top view you will see the true length. So this is the top view. So we have to draw the top view first when the lines are parallel to HP. So for drawing that, what we need to know what is the distance of A or B from VP. That will be given in the question. You find out from the question. Now here I am taking it as 15 mm from VP. So draw the XY line, and point A is 15 mm in front of VP, and this is the point A, and this line is here parallel to VP. So this is parallel to VP, and this is A dash, A, B, and now you draw a projection from B. With this the top view is completed. Now the second one is I have to draw the front view. The observer is looking from the front. When the observer is looking from the front, he will see here this distance and this distance are equal, and this distance and this distance are equal. So in both the views you will see the true length. Okay, so for drawing the front view, you have to identify what is the distance of this point from HP. So you identify this point A, what is the point A distance from HP, and you take, here I am taking 10 mm above HP. So A dash is 10 mm above XY, and I am drawing the horizontal line. Since the line is parallel to HP, the distance of all the points from the XY in front view is equal. So this is the front view. So with that, the projections of the line parallel to both HP and VP is completed. Now next we will see the line inclined to VP. The line is parallel to HP and inclined to VP. So this is the plane, and the line is inclined to VP here. The line is inclined to VP means here you can see there is some inclination with VP. Okay. Now when this is inclined means the distance from VP is not equal, so but the distance from HP is equal. So the lines are parallel to HP means the distance of C and D from HP is equal. So in top view you will see the true length. So we will start with the top view. In top view you will see the true length because the C and D are equal distances from HP. So this is the top view, and you will see the inclination here. Here you will see the true inclination of the line. Whatever inclination is there, that will be seen in the top view. Okay. Now once that is known, what you have to do? I have to identify what is the distance of C or D from VP, and I have to start drawing the top view. So take the XY line, and I am taking the C is at a distance of 5 mm from in front of VP. So the C is here 5 mm below XY line, and I am taking the inclination of the line as 40 degrees. So this is the 40-degree line, and this line length is 20 mm. So with this the top view is completed. To drop the projection from D, the top view is completed. Now you have to draw the front view. So in front view, you observe this carefully. Since the distance of this line, this point C and distance of D from VP are not equal, you will see a reduced length here. Okay, when the line is parallel to HP and inclined to VP, okay, you will see a reduced length in the front view. So this reduced length we have to draw. So this is the front view. Now for drawing that, I have to find what is the distance of C or D from HP. So I am taking 5 mm above HP, 5 mm above HP, and since the distance of C and distance of D are equal from HP, I will draw a horizontal line. With this, my front view is completed. Next one is when the line is perpendicular to VP. When the line is perpendicular to VP, how to draw the projections. So here the line is perpendicular to VP. You can see here the observer is here. What we are focusing on, lines parallel to HP. So when lines are parallel to HP, I have to look in from the top view. So top view, you will see the true length. Why? Because the distance of E and distance of F from HP is equal. In top view, you will see the true length. So this is the true length. Now what I have to do, I have to find out, this is the top view. Now I have to find out what is the distance of E or F from VP, and then I start drawing the top view. So this length here I am taking as 5 mm. So that this is the XY and this distance is 5 mm. E is 5 mm in front of VP. So E I am taking 5 mm below XY line. So E is 5 mm in front of VP. And with once I know the point E, I can draw a perpendicular line because the line is perpendicular to VP. So the line is perpendicular to XY here. So once this line inclination is known and the length of the line is 20 mm I am taking. So with this I get E and F. Okay. Now with this the top view is completed. Once the top view is completed, I have to go for the front view. When the observer is looking from the front, this point will coincide with this point and he will see a point here. Okay. This entire line will converge as a point in the front view, and this is E dash and F dash. So for drawing this front view, I need what is this distance. Once I know this distance, I can draw the front view. So here I am taking 10 mm above XY, above HP. So this is 10 mm above HP, and this point here I am getting a point here, and this point is E dash F dash. So with this the front view is also completed. So these are the conditions for lines parallel to HP. So when the lines are parallel to HP, so important points that we should remember here: when the lines are parallel to HP, in top view you will see the true length. See here, in all the top views we will see the true length, and the inclination of HP is also seen in the top view. Okay, so inclination, true inclination and true length of the line with HP, true inclination with HP and true length of the line will be seen in top view when the lines are parallel to HP. Okay, the true inclination with VP, so here it is perpendicular to VP, it is inclined to VP, and it is parallel to VP. So the inclination of the line with VP and as well as the true length of the line is visible in top view when the lines are parallel to HP. So this is one point we have to remember. The other point is when the lines are parallel to HP, in front view all the points A dash, B dash are of equal distance from XY, and C dash and D dash are equal distance from XY, and E dash, F dash are equal distance from FY. These are the 2 points we have to remember while drawing the front views. Okay, with this I close this session. Thank you very much.